Some of you might have seen me talk before, so I spent the last few years at Cohesive Networks doing cloud networking and security software, and I think it's there that I got to really first experience hands-on the world of DevOps. Before that, I spent about a dozen years in financial services. I think one of the twists I've kind of realized in the last few years is financial services had DevOps in the 90s, and then it got crushed under the heel of the kind of three waves of regulatory pressure with things like SOX, Y2K with people saying never again, and the mega mergers that took place with Solomon's going into Citi and CSFP turning into part of Credit Suisse, etc. I'll let DevOps Bharat provide my intro here. Okay, so I'm going to start out talking about the organizational context because I think a lot of DevOps is about organization and culture. And my preferred definition of culture here is the way we do things around here. And that's shaped by the organization. I'm then going to explain what I actually mean by DevOps. I think too many of the conversations that I have are still about tools, or hiring people into a role that's got DevOps in the title. And I think actually those things are pretty unhelpful. I'm trying to stop people at my company from saying DevOps in a box, as if it's something that can be, have a price sticker on it and sold that way. I'll move on from that to talking about operational data mining. So this is something that we're specifically doing in the ops area that I look after. And I'll explain the terminology, and I'll explain what we're doing with that. And then finish up with a look at the people, process, and tools aspect. So, of course, there is some tools piece to this that I've been doing for about 10 months now. So I've been at CSC since the beginning of last December. So I've just passed 10 months. I'm just reaching that point where people are going to start actually treating me as part of the furniture and accountable for the things that are going on. And I can't just kind of go, oh, it was all of those guys before. So the organizational context, where do I fit within that organization and what are we doing? So let's get the Conway's Law stuff out of the way first. Most of our customers are still split into the familiar two towers model of dev and ops. And the way that we choose to sell to those customers is to organize ourselves along exactly the same lines. So we have Global Business Services, GBS, does dev stuff, and Global Infrastructure Services, GIS, does ops stuff. And I think part of the issue that I see here is we're just kind of perpetuating the model of the past in some ways by organizing ourselves along those lines. And there was talk as I was joining about some reorgs, but we're doing a big merger in the course of the next year. So we're going to have to wait a little for that. There's also, I think it's worth looking at how we do delivery. And we spent the last few years, prior to my arrival, reorganizing how we did delivery and centralizing delivery into things that we call pods. So pods are where we've co-located people that do delivery stuff. Here in the UK, we've got a handful of them. The big ones are in Chorley, in what used to be BAE's facility there, which was an army facility if you go far enough back, and Chesterfield. But there's a few other littler ones sprinkled around. We try and have a global delivery model out of India, so we've got 3 massive pods in India. But each pod runs the same model, this thing that we call IDO. And we have these different pieces within it. So iAction is level 1 support, whereas iBuild is sort of level 1 proactive stuff. So if we think about the difference between a trouble ticket and a change request, a trouble ticket is going to come into the iAction people, whereas a change request is going to come into the iBuild people. If we go back a bit further into the sort of level 2 and level 3, then we get into iSolve, dealing with the trouble tickets, and iEnhance, dealing with the change requests. We go right the way back, then we've got the deep expertise in iGuide. And then this is surrounded by some supporting structure here with iServe, iTouch, iAutomate, and iIntegrate. One of the things that comes out of this is all of the toil, if you're familiar with that word, and I'll come back to where it comes from later, lands at the face of iAction. So we've got people there who are just kind of facing a wall of tickets all day, every day. Ticket, 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 ticket comes into them. And then if they can't immediately resolve that, they're passing that wall of tickets back to the iSolve people. Whereas those that are working in iBuild, iEnhance, iGuide, iBuild is driven by the change request tickets, but it's less of a reactive thing. And what can happen here is you can basically kind of get promoted out of the front line and not have any toil anymore and lose contact with what's going on a day-to-day basis and the problems that people are experiencing. So what do I mean by DevOps? Well, an observation I'd make is if you look at just about any product or service, then it goes through 3 stages of industrial design maturity. And I like to use the example of cars as I have done here, because it's something that we're all pretty familiar with in our everyday lives. So if we go back to the beginning, design for purpose was when Mr. Daimler took a carriage and turned it into a horseless carriage by putting an internal combustion engine into it. And you can kind of figure that at that point, there was a bunch of blacksmiths running around after this thing because there was no such thing as a car mechanic. And then along came Henry Ford, and he moved on to design for manufacture. So Model T, any color you like as long as it's black, production line manufacturing, consistency. And then finally, we've moved to design for operations. So if we look now at how, let's say, a modern BMW is designed, it's designed to take into account that it's sold with a 5-year maintenance contract. And so BMW are now having to bear the costs of that maintenance contract, and that affects the design of the car. So they'll put the oil filter in a place where it can be reached in a matter of seconds and changed out, because they don't want an oil filter change as part of an annual service to be taking an hour. Whereas if you go back to design for manufacture, if it was cheap to put the oil filter on the bottom of the engine, it didn't matter to them that it was going to take you 3 hours to kind of chain it out of the engine bay just to do an oil change, because that wasn't their cost. That was an externality. It was a cost that could be passed on to the customer that didn't matter the manufacturer. So we can observe that exactly the same design evolution has taken place with software. We started out with computers that were designed for a single purpose, code breaking, at the very beginning of this, but then early industrial applications. And we moved through packaged software, which was designed for manufacture, where it's quite clear that a lot of packaged software makers didn't care about our costs of using their stuff. An entire industry sprung up around that. And then we end up with today's world of software as a service and software-based services, where the people making that software appreciate that they're having to bear all of the costs of looking after that stuff. And the tools, practices, and techniques that have emerged from that of what we ended up calling DevOps. Now, of course, the issue that I think we see most in the enterprise at the moment is if you go back, most enterprise software is still designed for purpose, and we've got the modern-day equivalent of blacksmiths running around after their applications, trying to mend them every time something goes crank. In a business context, we can see the gains that can be had here. So some numbers on the left-hand side from the most recent DevOps report. The gap is widening every year. If I was to go back to the 2015 numbers, they weren't anywhere near as impressive as this. And I won't be surprised if the 2017 numbers are pulling further ahead. And this is against average. This isn't against worst in class. So average is kind of staying the same, and best in class is pulling ahead. And that's enabling business agility. So Netflix is a machine designed to adapt to customer need. And so many other organizations are now figuring out that they can win in their competitive environment by adapting quicker than those around them. That business agility drives the need for software agility, and I'm sure pretty much everybody in the room is familiar with the Agile Manifesto and everything that's come from that. And that drives then back into a need for agile infrastructure. So this is what I've been meaning by DevOps. Who in the room's read Phoenix Project? Oh, okay, so about 40% looking at the hands. And has anybody yet picked up DevOps Handbook? I know it was only published in full last week, but just Owen. Just Owen. Whether it's the Phoenix Project or the follow-on, which is the DevOps Handbook, then there are 3 ways that are kind of proselytized here for doing DevOps. The first is flow, to have better flow of work through your pipeline. The second is feedback, to be able to know when something is going wrong at the earliest stage in order to take corrective action on that. And then the third way is about continual learning and experimentation. So I thought how I would frame this is to look at, if I'm sat in ops in a 2 towers organization, as I am, so I've got a few thousand people out in these pods and these delivery centers doing ops for people, then how can I adopt the 3 ways? What can I do that's DevOpsy when all I've got is ops? So flow. If we look at what Gene and John Willis and Jez Humble and all of the crowd talk about when they talk about flow, it's about reducing the size of the change that we're making in our software to as small as possible so that we can push it through our continuous delivery pipeline as quickly as possible, and that gives us flow. Now, I've got my giant red "You Are Here" arrow to show where in a classic DevOps handover we actually get to see the flow. So my problem here is, even if the dev part of the organization is running CI, and that's a big if for many IT organizations at the moment, then as an ops person, I don't get to plug into that until the last stage of the whole process. So although as an ops person I can then start looking at my own flow and thinking about how I can reduce units of work in order to achieve flow through ops, in terms of the applications coming to us, I don't have control over the CI, and so I don't have control over flow. So that's a bit problematic. Feedback, the second way. This, sadly, is pretty much the same story as flow. So if I'm doing CI, then I'm getting feedback straight away if I've broken a test. Doesn't matter whether it's a unit test or an integration test. Something's turning red in my Jenkins, and I know that I need to go back to the code, make some changes, check it in again, run it back through the automated tests. If I'm sat at the end of that process, then I'm not getting feedback that I can respond to in a timely manner as I'm pushing things into the ops environment. Now, just like with flow, I can think about instrumenting the ops environment itself to give me as much feedback as possible, but it's that end-to-end piece that's missing. So both of these examples, the lack of control over flow and the lack of control over feedback, are the lesson of why, as Adrian Cockcroft says, DevOps is a reorg. So if you want to be doing this properly, then you need to think about the reorganization of how you do your software development into ops, and you can't just kind of keep the existing model and put a DevOps Band-Aid onto it. But it's not all bad news. So the third way does work. And you can do stuff about the third way in a purely ops environment. And the label we've given to this is operational data mining. So I've got all of these exhaust pipes showing here because we take the data exhaust from every service management and ancillary system that we've got in the ops environment. And we take that data exhaust and we do experimentation as a result of the analysis that we get from that. So the exhaust goes into an analysis package. We flow it through there. We figure out hypotheses about what's going on in the environment. And then we run experiments. And I'll talk a bit in a moment about some of the experiments that we get to do. What this has driven me towards is something that I call all in on operational data mining. So I don't want to be making any decisions about my operational environment unless I've got data that I can do analysis on that will give me a hypothesis where I can run an experiment in order to figure out what's going on. And another thing that is kind of central to both Phoenix Project and DevOps Handbook is theory of constraints. So what happens here is the data will tell me where the constraints lie. And actually, for most of the operational environments I see at the moment, the data is just so obvious in telling you where those constraints lie. Anybody want to have a guess at what the number one ticket issue is in just about every environment? Shout one out. Passwords, did I hear? Absolutely right. Password resets. And it's not even password resets themselves. It's the consequences of changing a password. The worst example I've seen from this was an environment where they decided to use EAP for Wi-Fi login. And what this ended up doing was relating people's bring your own devices, like their iPhones, to the Active Directory environment. And so what would happen is this. Somebody would come in the morning, and their 90 days would be up, and they'd go change password through the password manager, and the password manager would change the password, and it would all be good. And then a few minutes later, they'd try and do something, and it wouldn't work. A password would be locked out. So they'd call the help desk, get their password reset, and a few minutes later, it would happen again. And it's like, what is causing this? Well, it turned out what is causing this is their iPhone sat on their desk, and when they've changed their password, immediately it tries to reconnect to the Wi-Fi after a little timeout, and it's using the old password. And it tries and tries and tries to connect until the password gets locked out. And it keeps on trying. So that interconnection had caused the problem. I'm on a bit of a mission now about passwords because both CESG and NIST have recently published very clear guidance that password resets on a regular basis are actually a bad idea. And wouldn't it be wonderful if we could get our customers to stop doing this? And the minefield I face right now is how many regulations, not just in-house policies, have encoded this bad practice of the past into something that people think that they must do. But the data very clearly shows us these constraints. And then when we find the constraints, the data is actually pretty good at telling us what we need to do about that. And when we run through that exercise of collect data, analyze, hypothesize, come up with an experiment design, this is what I hear from our frontline staff. I knew that. I knew that we needed to do that. And at this point, it's kind of difficult not to get angry and sort of go, okay, then why didn't you do that? And what we figured out here is that data is providing a means of empowerment to people. So we're taking away decisions from the highest paid person's opinion, and we're putting it into the hands of frontline people supported by the data that they see every day in their environment. And so that's allowing us to do stuff that seems obvious. I'm looking forward to, I expect, next month or two, probably by the end of this calendar year, we'll start running experiments that fail. Because pretty much all of the experiments we've run so far have been so boneheadedly obvious that they've all succeeded. Because that will tell me that we're actually starting to do experiments that find the edge of our operational envelope rather than just driving us to being well managed. So the experiments that are driving us to being well managed are making enormous gains in the operational environment and improving quality and reducing cost and all of the good things that we could hope for. But I think it just takes us to being good, not great. Whereas the experiments that start failing and finding that edge in the organization will actually take us to being great at stuff. So I talked about DevOps being this emergent set of practices. And so what do we actually need to change in terms of our people, process, and tools within the organization to get this stuff done? So we do this thing called an infrastructure as code bootcamp, and I find myself, internally at least, mostly talking about infrastructure as code rather than DevOps, because it's the whole, how do I do DevOps when I don't have any dev? And so I reduce the scope down to, let's do some infrastructure as code. And I think we've got a huge problem, not just in my company, but not even in this industry, but perhaps across pretty much the whole of educated civilization, that we spend the first kind of 15 years of somebody's education life telling them that they're not allowed to copy stuff. Don't do that, it's cheating. So I open up these boot camps by saying to people, I want you to cheat like crazy. I want you to copy from everything that you can possibly find. And I want you to share with your colleagues in order to get this stuff done. The bootcamp that we do, it's all run out of GitHub, and it's all documented in a GitHub wiki. And I'm going to have a speed run that I'm going to do on a webcast in a few weeks' time, which is somebody's given me a 15-minute window to go through what's normally a half-day bootcamp. And I think that's actually going to be comfortable. I think it takes me about 8 minutes to speed run it on my own. So 15 minutes with a narrative shouldn't be too difficult. So it's like, if you're good at copying, it should only take you sort of 10, 15 minutes to go through this stuff. So what do we actually do? Well, the first part is Git. So it's all about getting people's feet wet with the tools. And for me, the first change that I need to make is to get operations people to start behaving like software developers. And that doesn't mean picking up an editor and writing code. That means starting to be disciplined about what they do with artifacts. And this has driven a realization that we didn't give ops people source control back in the day, because source control was $2,000 a seat, and they weren't considered worth it. So that's why all of their scripts and stuff live on home drives and NFS shares and all manner of things, which makes them impossible for other people to find and collaborate around. I pay particular attention to fork and pull. And the point that I make with this is I want to move the culture of the organization from asking permission and waiting for that to be granted to begging forgiveness and just getting on with stuff. And fork and pull, for me, is a great example of a mostly beg forgiveness environment. So when we do a fork and pull, the only point where we actually ask for permission is for the merge back into where the fork came from, where we're asking for the permission of the original creators of that stuff to say, hey, do you think my change is good enough to add back into your thing? The rest of the process is completely autonomous. People can get on with it. They don't have to ask permission. They're not being held up. Configuration management is the next piece. And we happened to pick Ansible. I happen to think that Ansible is the least bad of the configuration management frameworks. If you want to know what I don't like about it, happy to answer those questions in private. But we picked Ansible for a variety of reasons, and so we spent some time looking at what Ansible can do, just as an example of what configuration management can do. And I spend a bit of time talking about the differences between imperative configuration management, which is what we get to live with, and declarative configuration management, and oh, wouldn't that be nice? And then Jenkins, as an example of CI. And I use some parts from this definitive guide and the examples that go with it. And we sort of start out in chapter 1, which is let's build a CI pipeline. And we skip then to chapter 11, which is let's deploy some stuff into production, because these are, after all, ops people, and that's what they do. And I kind of say, okay, we glossed over chapters 2 through 10, which are testing, 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 and more testing. And kind of that's what developers are spending their time doing. And at least you've got your hands dirty with some of the tools that they're using. So this is something that is a bit of an English language idiom. But there's a reason I've got a picture of some pig's ears on this. So something that we find is that even when you've got a perfectly honed runbook in a wiki that people can copy and paste from, that has been polished by hundreds and hundreds of people using it, that people still mess it up, even though it is their day job to take stuff out of runbooks and run stuff. And this, for me, is the perfect example of why we should actually be using configuration management tools, because if people can mess stuff up in a copy-paste between an essentially perfect wiki and a shell that's right beside it, then it shows the human frailty can't really be dealt with at any kind of scale. And the reason it takes us 3 or 4 hours to run one of these workshops is the time is spent dealing with people as they get stuck. So we have a facilitator in each workshop, and when people get stuck, they go and help them out. And when people get stuck on the same thing in quite a few places, it becomes a learning point for the whole workshop. And we sort of amble our way through them that way. The other thing that comes out is doing root cause analysis properly. So I've seen far too many now superficial root cause analysis of kind of, this broke, and so the root cause analysis is the thing broke, and the solution for the future is we should not let the thing break again. That kind of answered one why. Why did it happen? Well, it happened because of that. What are we going to do about it? We're not going to let that happen again. Far too superficial. So I've put 5 whys up here because there's a bit of a movement that if you actually ask 5 whys, then that gets you to the proper root cause. And you can then start having a conversation about what broken thing in your culture allowed this to happen, and stop having a conversation about a switch failure or a SAN outage or whatever it was at the technical level, because fixing switches and fixing SANs is kind of business as usual, and you should be ready to do that. But when switches and SANs fail, it shouldn't turn into a catastrophe because it should be business as usual. And if you ask 5 whys, you can start getting to the cultural things that underpin that. So I've been talking for about half an hour. It's time to start doing some wrapping up. And if I kind of review what we've been through here, I first looked at organizational context. And my organizational context is living within the 2 towers model that's ruled IT for far too long. And what I'm asking here is, how can we do at least as much DevOps as we can in a purely ops environment that's kind of separated because of the 2 towers model? I talked about what I mean by DevOps and industrial design maturity, and that shift from design for purpose to design for manufacture to ultimately design for operations. And that in software, DevOps is really the set of practices that have emerged from these companies that have achieved design for operations for their environments. Then operational data mining. That you can take an ops environment, you can take the data exhaust from that environment and use that for organizational learning and experimentation. Use it to identify the constraints in your environment and use it to help you decide what to do about those constraints by that experiment. Then the people, process, and tools bit. Get people's hands wet and feet dirty with this stuff. It really, really helps. We've had hundreds of people now through the Infrastructure as Code bootcamps. And one thing the GitHub people tell me is once you get somebody to do a pull request, they're 90-something% likely to keep on using GitHub. And we see that in the logs that we get out of GitHub, that having got them to do a pull request, they're familiar enough with the tool. There's a joke meme, an oh really book cover going around of six Git commands that you need to get by. I counted through the bootcamp, we only used 5, and I'm like, oh, what's the missing one? Which was, of course, git pull, because we only got people as far as a pull request. We weren't actually having them pull back the results. So we now do talk about that. And then we throw in a few bonus ones, like git status, once people get into trouble and they're kind of trying to figure out what's going wrong. Some recommended further reading, in addition to Phoenix Project and the DevOps Handbook. And by the way, DevOps Handbook, I'm finding it outstanding. I'm telling people to jump it to the top of their reading list. It really is just very practical in outlining the changes that you need to make in an organization to improve. But site reliability engineering, this resounds a great deal for me because it really is the sort of ops-centric view of applying industrialization and infrastructure as code to an organization based on the war stories out of Google. And then the infrastructure as code book itself from O'Reilly is also pretty good if you want to get into more of the detail of kind of contemporary infrastructure as code systems. I opened with DevOps Bharat, and I shall also let him have the closing. Please vote. Sorry. And I think I should have some time left for questions.
You mentioned organizations which have 2 tiers, sort of dev and ops, but a lot of organizations have got 3 towers, if you include support. What do you do with that? Do you fold it away? Do you push it into one of the towers? Is it an impediment or an advantage?
I think it's actually an advantage. So you and I worked in the same place for a little while, and I saw them doing this just as I was leaving, which was creating the support group as a sort of almost a buffer zone between dev and ops. And I think there's a parallel here with kind of the pioneer settler town planner thing that Simon Wardley talks about versus a bimodal approach. So dev and ops and the split between them feels to me like bimodal. And the wall gets thrown over. Whereas the pioneers, settlers, town planners is all about managing the middle and managing the transition from one extreme to another. And I think organizations that have gone along the way of having that 3-stage approach, of having ops as a provider of infrastructure to app support and dev as a provider of code to app support, have built an organization that is capable of managing the middle. Now, I think it's still a transitionary stage. I think especially in financial services, I'd love to see them win the way back to that DevOps that I feel they had in the 90s and to be much more responsive to the need for business agility. But even then, applications become a portfolio management exercise. So if you take the pioneer settlers, town planners model, then the DevOps stuff is really for pioneers, and then you have to think about how the settlers do the transition into town planning for the steady state stuff. The mainframes are still around. The mainframes are still providing value, otherwise they wouldn't be still around. And I don't think you necessarily need to be applying flow, feedback, and experimentation to your mainframe application that's been working since the 60s. You just need to find people that are not about to retire that can still look after it for you. Owen had his hand up, but let's get some.
Sorry, he was first. Can you come forward, please? Thank you.
So the question is, how would you deal with a thing I often hear when trying to help people into a DevOps mindset is, I will just do it now, and then we'll automate it later. And you often find people just fixing it now, and then they'll backport it into ops. How would you?
So that's the very way that we create technical debt. I'll kind of turn it around, and I'll give you an example of a CIO I was visiting recently was saying to me, how do I get started with this? And one of the things he'd just been moaning to me about was every new developer that he had joining him took a week to get their dev environment because they were yak shaving. And what I said to him was, next time you hire a new developer, get them to build the template for the one that comes after him. And it's going to take him more than a week. Might even take a month or two, but it'll be worth it because you're going to have your payback in a few developers' time. So it's looking for those opportunities to not just not create further technical debt, but to create an investment that's going to give you a payback. And I think if you take that mindset, you can get the appropriate balance between the yak shaving and the investment in automation.
I wanted to go back to the bit where you talked about the CI pipelines and not being able to influence development and ask you a bit about that, because it struck me that why could you not influence them to do the right thing? But then if they can't, surely ops have a huge problem that they don't. There may be an automated pipeline, but their confidence in what's coming out of it, if they've not been able to influence good practice up in the CI part of the pipeline, surely very low. So what do you do with that risk if there's a customer that won't play ball?
So actually, one of the things going on here is only a fraction of what we're doing in ops is bespoke development. A lot of it is the rolling out of and configuration of those packaged software things that come from the whole design for manufacture. So most of the ops we're doing, I would guess at, is living with that economic externality of design for manufacture in software, that they don't care how much it costs to own packaged software. That said, it's kind of, those guys these days have mostly got CI in, well, not CD, because they're shipping to a website, they're not shipping into production. And so there is no control over there. Where there is a connection, where there is bespoke software, I think there is an increasing demand for let's turn CI into CD. And we're beginning to have the conversations with those customers about, okay, if you're contracting us on the ops side and maybe contracting us on the dev side as well, and you're asking us to now join those two things together, then let's collectively go through the organizational change that's needed to give the feedback all the way back.
So I want to ask, at some point during your talk, you mentioned that you have been conducting experiments that haven't failed yet. So my first question is, what kind of experiments are you kind of having in mind? What are you doing? Is like something like chaos monkey type of experiments, or switching this on to see what happens? And why didn't you fail yet? Are you not pushing hard enough?
I'll start with why haven't we failed yet. We haven't failed yet because we haven't moved past the obvious. So every single constraint that the data's taken us to has had an obvious answer, and when we've run the experiment to prove that out, it's kind of immediately lit up that this is something that we should do in production. To give you an example of the type of experiment we're doing, we had an environment where we were regularly failing to respond in time to inbound phone calls in the call center. And so the data scientists modeled this out, and the experiment that they came up with was to bring the call center people in half an hour earlier. So what had been happening was everybody began at 9 o'clock in the morning, our call center people and their staff. And by the time our call center people had come in, clocked in, grabbed a cup of coffee, sat down at their desk, logged in, taken the first ticket, they already had a wall of tickets that they were being assaulted with. They got overwhelmed in the first half an hour, and they didn't recover all day. And this is what happened every day. And most days, at some point between the wall of tickets at the beginning and never recovering until the end, they would trip over their SLA limits, and we'd start to then owe fines to the customer. So the bringing them in half an hour earlier was simply about they would have their coffee and get logged in and be ready for the first tickets as they came in. And the data told us that if we did that, they would probably never be overwhelmed, and we would probably never go outside of the SLA. And that's exactly what happened. Very straightforward. Now you start asking the whys. How did we let this happen in the first place? And so we asked the why of what determined the shift pattern for the call center people. And it was the software provided by our telephone exchange manufacturer was used for scheduling the operatives. And this stuff's designed to optimize how many people we've got there. They're expensive, so we want to have as few as possible. And so it was designed to keep them busy. It was not designed to match the SLA. So we had a fundamental misalignment of objectives in how we were scheduling people, and we'd been doing it wrong for years and paying fines as a consequence.
Thank you very much. I think we're done now
We're out
with
of
the
time, are we?
time. Sorry.
Thank
So
you,
thanks
everybody.
again.